Yeah, thank you for going through that exercise. So what I mean by the ID potentially being nil is ever since day one, when we've been creating Ruby objects, we were able to just say .new and have access to all the data and create a height, create a mountain, and create a person off of class. So I have a solution that I wrote up with you all while you were in the breakout room. So hopefully this looks similar to what you came up with. Our hike is going to have a mountain ID and person ID and a name. Let me run the hike query. So there's ID, name, mountain ID, person ID. So that's exactly the same here. With optional parameters, you do need it at the end. Actually, that might not be true. But yeah, put ID at the end, just by habit. And then we have our adder accessor for now, which is fine. And then you set those instance variables. And for the self.all, we're just going to say select everything from hikes because we're in the hike class. We can execute that, and then we create our hike object from whatever's returned in the database. So my data inside of the database is always going to have this primary key ID 1, 2, 3, 4, 5. However, let's say I just want to use a hike normally within my Ruby program. When I create a new instance of a hike, it's not from the database. It's just data that I'm creating inside of my program itself, and that's not going to have an ID. So because I made ID optional, when I create a hike and I want to use it within my Ruby project, I can just say hike.new. Now I need to give it some random person ID. We can do that. I can say like new couch, that's the name, and like 3, 4. So that's my 4. And it's not in the database, so it's not going to have an ID. It's just going to be a normal hike object. So I still have the ability to do a normal creation of an object instance without having the need to represent an ID for it, because this ID is only coming from the database. So that's the reason that we make ID optional, because if we want to work with just random Ruby instances in our program, it's not going to have an ID. However, once we save this to the database, it will have its own unique ID created once it gets added there. So when you do the insert into and you put all of the information in here, then it will have an ID. But when I create it in my Ruby program, it's not going to have one. Any questions on that?
Instead of hike.new, if we write hike.create, so it's go in the table, hike table.
Yeah, so for now, we only have new available to us. We haven't written a create method yet.
Okay.
I was gonna ask if you could repeat about we don't have to pass the ID a number yet when we're trying to save it to the table.
Yes, because this ID represents the primary key of this row in the table. And if we're just creating some random instances in our Ruby project, it's not in the table yet, so it's not going to have a primary key.
Okay.
Yeah, but once I do like an insert, so let's say we still have our DB connection available to us. So I can say db.execute, and I can say insert into, oh wait, this is a string. Let me see if I remember my inserts. I always forget my SQL queries. So it's name, values, and then I could say new couch. And I also need ID. So I'm going to say mountain ID. Person ID. And then I'll just say like 1, 1. Oh wait, Alec, are you asking a question? Wait. I think the mic is getting a lot of feedback. We're not able to hear. Oh wait, now it's fine.
The upside down.
The
Did you not understand him? I heard him.
How's now?
Oh,
Is now
we
better?
can hear you. Yes. I don't know what happened before.
I apologize profusely for all of the trouble with my Zoom. I'm so sorry, guys.
No,
yeah, okay, cool. That was what I was going to say.
Oh, okay. Thank you. Yeah, totally forgot. All right. So insert into hikes, name, mountain ID, person ID. I like the upside down. It's going to slowly recede. And we have our new couch and we have our IDs. So now if I do hike.all, you'll notice new couch is there with the ID of, oh, we need to assign it, the ID. Why are you new? ID equals, oh, because I didn't put it in here. So that's a bug we can debug. But right now it's all nil, because when I create the hike object, I don't pass in the ID. So let's fix that. Do, so I need to say hike ID. That's my copy paste mistake. And then I'll restart this so we can see it. So if I do this again and I say hike.all, I now have the ID of 6 that's coming from the database. So when I work with those Ruby instances in here, it's not going to have that primary key. It's just going to be nil. And that's like foreshadow into the future. Good indicator to double check if that instance exists in the database or not. If it has a primary key, it means it's in there. If it doesn't, that means it's not saving to the database in a sense. Cool. And then I think mountain.all, let's see if that works. Cool, mountain.all has all of the IDs in there, which is perfect. So this is what our self.all is going to look like. And I did the same thing for mountain. There's the name and ID column, matches up with ID and name here. And then I'm creating the mountain object here after we get that data from the database. So typically, if you want to work with that information inside of your Ruby program, just because objects are much easier to work with, you're going to add in that extra step of creating that instance after you get that data, rather than just passing hashes around. Clear this out. Any questions?
Can you repeat that one more time, please?
Yeah, so similar to what we're doing in the self.all, whenever we're getting data from the database, you don't want to directly just use that hash that's being returned to you. You want to convert it into objects so that we can call the methods on it and we can call the variables on it. So this is always going to be a two-step process. You're going to run the query first, and then you're going to convert it into an object. Cool. Good questions.
Any particular question why the person class is creating a table and we haven't done anything like that for the other classes? Or is that like next steps?
This is next steps. I did this when I was prepping because I accidentally did the table.
Perfect.
And I was too lazy to use SQLite browser. Yeah, so that's me. But that does bring me to the point. We just have self.all here, which is the read for my data, selecting everything. Eventually, you will write CRUD in here. So you'll have a create table, you'll have an insert into, update, delete, all that stuff. And that's what we're going to work on next. All right. So I want to practice writing a couple more together so that we can get comfortable with writing CRUD methods inside of our classes. You got a chance to write a self.all and doing the select query. If we're taking a look at top 8 queries here that modify the schema or the data, are there any preferences? You can just shout any of these, we'll write it out. Your favorite SQL query.
Can we do alter table, add column?
Let's do it. So alter table, add column. First thing you want to think about is, we'll work with the people class because that's the example I have here, is what information do I need to implement this query? So we already have our keywords alter table. This is something that we can hard code into our method. However, we do need the name of the column that we're going to add, and we need the type, so the type of the column. And because of our pattern, everything within the person class is only going to deal with the people table. So we can hard code this in, but we need to take in these things as parameters into our method. Now, when we're talking about alter table and combining it with our object knowledge thus far, is it going to be a class method or an instance method? What are your thoughts?
Would it be a class method?
Yeah, it's a good guess. It is going to be a class method. So if we're talking about making changes to the table itself, which is us adding a new column, we're actually making changes at the class level. So it's going to be a class method. So now you get to start thinking about, do I need an instance method to do this? Do I need a class method? I would say like 70% of the time, you're probably going to create a class method because it's dealing with the table or the class as a whole. There will be times where you can also make it an instance method. Cool. Let's do it. So we need column name, column type, and it's going to be a class method. Technically, we can call it anything we want at this point. So we'll say self.addColumn because we're adding a new column. And it needs to take in column name and column. I'm just being super explicit. However, type is a reserved keyword in Ruby, so you can't name anything type. So typically I just put like column or whatever type it is with the underscore before it. And then I'm Finding.pray. And feel free to stop me at any point and ask questions. And then this is going to be, to classify it, this is going to be an update to the schema. So always be thinking about CRUD. Which CRUD operation is this going to be? And then let me scroll to the top. I'll scroll all the way up here. This is in the person class. So I need to say person dot add column. And then I'll pass in, I think it was age and integer. We'll see if this works. I think it's my first time, or I haven't done the add column in here for a while, so we'll see. Column name, column type. So I'm in my pry, and my first step is figuring out the SQL query that needs to run this. So I'm going to copy and paste this in here for now. And the query that I want is alter table people set, wait, no, add column. And then technically with strings, you can definitely interpolate. You could be like, interpolate and say name, and interpolate and say column type. Oh, oops, column name. I like this. This looks correct. Wait, a semicolon just in case. So you can interpolate the values in here. We'll say column, and it'll probably work because string interpolation will take anything in and format it as a query. However, by convention, you should never just trust whatever the user is going to give you and pass that in as a value into your SQL query. So while this would work, and our SQLite database does a pretty good job of protecting like outside sources and outside queries from coming in, because execute can only run one query at a time. But there is this concept called SQL injection. And what that is there are hackers out there whose like true purpose is to hack your database, corrupt it, delete everything, and they just want to break all of the data that you have basically. So if you just trust anything that the user gives you, you could potentially take some random script that the user or the hacker is trying to implement. They could insert it into your execute command, and it'll break your database. Or maybe there's some kind of script that's going to read everything there and grab all of your data. It could be anything. So you always want to be protecting
Really cool.
your, yeah,
Okay.
dangerous, but cool. So you always want to be protecting the data that you're getting from the user and not directly running it. SQLite has a placeholder that we can use to kind of help us with this, but I usually like to introduce like Bobby drop tables Does that sound familiar at all? Bobby Drop Tables, maybe? There's this like hilarious SQL comic. I will introduce it to you all because it's hilarious. But it's a lesson on like SQL injections and why is it so hard to read this? Oh my gosh. Okay. So I'll like zoom in, take your time, read through this. It's great.
It's so good.
It's like super funny. I always like to introduce this comic. You'll probably see it later,
There's
later
an
in life too.
XKCD for everything.
Yep. This will delete everything. And that's basically what happened here. So someone, I don't know why they named their kid Robert, end quote, drop table students, but that's what this kid's name was. And they just like took it, they interpolated it, ran it against the database, and the database not only inserted Robert, but it also dropped everything. So protect your database inputs. That's the lesson. You don't want to accidentally remove everything from your database because you're not seeing what that table is. Now, our execute runs pretty well. As soon as it sees a semicolon after our query, or as soon as it sees an end of a query, it completely stops. So SQLite is pretty good at protecting itself. So it won't take in any extra commands or queries or parameters. However, you do want to practice good convention from the beginning. So rather than us interpolating the values that we want, we are going to use placeholders, which is going to look like these question marks here. So our string itself, the values that we want to pass into our query, let me hit enter, is just going to be question marks. And what ends up happening is our SQL method, let me call this hikes equals our execute method, and I'll hit enter here. Cool, so we got our SQL query. Our execute method has more parameters that it can take in for values that you want to pass into this query. So we're going to say the first parameter is the SQL query that I want to implement. And the second parameter is going to be the column name and the column type. Order does matter because this is going to take column name and it'll put it here. And this is going to take column type and it'll put it here. Let me see if this goes through. Syntax error. No. Oh, I don't know if I can add column with the SQL query.
Could you repeat again why we would use the question marks?
Yeah, so these question marks end up being a placeholder for our SQL string. And what it does is it says, I'm going to get some extra parameters, or there's going to be some extra arguments passed in here. And it's going to take in this column name and it'll put it in place of this question mark here. And it'll take in the column type and put it as question mark here. So anytime, yeah, of course. So anytime you're getting like extra values from your method call, you can use placeholders instead. Except I don't know if I can do an update or an alter table from the SQL query.
I think you've got just an extra single quote between the question mark and the semicolon.
Thank you. Oh wait, let me copy paste it. I'll redo this. Clear this out. Sweet. Thanks for spot checking, y'all. No, okay. Add column.
It might be question mark, comma, question mark.
I think does the quote have to go? Oh, never mind.
No, I think it might be the add column query. I don't know if I can pass it in as a method. Let me double check my syntax. Otherwise, we'll do another CRUD operation and I can show you how to pass in parameters.
Mine worked the same way that you did it.
It worked?
Yeah, with the 2 question marks.
Nice. Yeah, why is my, whoa. This is not the best documentation. Let me go back. Let me do add column example. No. If it works for you, then maybe I just have some kind of alter table, table name, add column, new column, and then the type. That looks right. Add column, new column, type. I don't know. We'll come back to this because I'm not sure if it's the alter table that's stopping it or if it's my SQL query. So we'll try implementing another one and see if it's the SQL query itself. If you notice any typos in here, let me know if you'd like to fix it. But I feel like this matches what the other one was too. There will be specific things when you're modifying the schema that it's not going to allow you to do from the class, which could be another reason why this alter table is not going through. But if we're trying to modify data inside of the table itself, the actual row values, then it might go through. So we can try that. So let's try an update from, we'll try a different one just to see if it goes through. We did a select. I guess we could do like an insert. Why not? Okay, we'll do a create for a person. So this is our query. Hopefully this one works through. And then same question. If I am inserting new data, is it going to be a class method or an instance method? So we're looking at this
Instance.
Instance.
Could make it an instance method. So let's do that. And if we're making it an instance method, we have access to, we need to create the instance first. So we'll have access to the name that we want to insert. And our method, all it's going to do is save, or it's going to pass that query to the database itself. So I'll just call this like insert data. Cool. So make it an instance method. Does it need to take in any parameters? Question number 2.
Name.
So pass in name. For an instance, there is another way that I can get the name. It's through my instance variable that I initialized here.
Completely forgot about that.
Oh, it's totally fine. If it's a class method, you do need to pass in the name. If it's an instance method, you have access to that data. That's why it'll vary depending on what kind of method you make it. So let's try building it out with without passing in any parameters. Now the cool part here is insert data needs to be called off of an instance. So there's actually one step that we need to do before we save it to the database. We need to create that new person. So I'm going to say p equals person.new. And I'll say Ahmed. Cool. All right, so I create my new instance. And notice how ID is null because we haven't saved anything to the database yet. However, I can call this insert data off of my instance variable and then execute that query. So I can say p.insert data. And because this is an instance method, I have access to the adder accessor that I've set up in here. So I can say name and I get access to the name, and that's about it. That's all it has. ID is going to be nil because we haven't added anything to the database yet. But my SQLite query for this one, let me copy paste this. This one didn't work. I hope I don't have a copy paste error. But for this, it's going to be insert into people, and then it's going to take in a name and values. Same thing. I'm going to put the question mark here because I want the placeholder for this name. So I'm going to say SQL and name. So I'm not getting any parameters for the method itself, but I still need to pass in the name that this query needs in order to run. So let me create it here. Insert into people values. Let me try to execute it. I also put in hikes when it's actually the people class. So what am I even doing? All right. And then, so we didn't get an error back, which is good. That's an indication that anytime you're modifying the schema, the class is going to be a little bit more protected. So something to keep in mind. And if I say person.all, I have the new person added. I haven't refreshed my database yet. So if I go, oh wait, never mind. If I go here, I get 8, and I can technically do that again if I want to. And then I have 9 now. So I don't actually get that ID assigned until it's saved to the database. That's the main thing. And because I made this an instance method, I need to create the person.new first. And then there's that extra step of saving it to the database. All right. And then we can even take it a step further where we said, now if I want to actually return the object again, you'll have to add in that step of selecting everything and then converting it into an object. Any questions so far? Cool. So we got to see schema is a little weird for writing methods, but we got to see an example of how to take in parameters and actually pass them into our SQL query. You're going to do them with these placeholders, the question mark, and pass in the variable that you want into the execute method. And that is going to be the general pattern for any of the CRUD methods that you write. I am going to break for 5 minutes and then we'll come back and I'll talk about ORM relationships and we'll make hike, mountain, and person communicate with each other. All right.
Sandaria, do you think you could update this to Git so that we can pull it up?
Yeah, I will do that right now.
Awesome, thank you.
Sweet. Sweet. So if you do a git pull, you should have access to all that stuff. It needs to be at the end. Hike.new mount. Oh, I just saw this Slack message, or yeah, Zoom chat. It doesn't like placeholders on alter table. Sad. That's what I get for blindly going in. I was like, let's do it. And it's like, no. All right, I think it's been 5 minutes, so I'll go ahead and get started. I'll wait for people to show back up. Welcome back. Hopefully you got a chance to take a break. For me, it's literally like sitting down on my chair. I'm like, okay, time to get up. Let me stare at the wall for a little bit. All right, so, oh, I was still recording. Oh, well. You're gonna get some silence during the rewatch of this, but that's okay. Let's go ahead and pick up where we left off. We kind of got an idea of how to communicate with our database now and run our SQL queries and somehow use that data or insert data into the database, basically just performing our CRUD operations. We'll never have time to like go through each CRUD operation and implement it out. However, the idea is going to be the same. No matter what SQL query that you're going to write, you're going to figure out what parameter do I need to pass into that method, whether it's an instance method or a class method, in order to execute this query. So you can literally take any of these queries. We kind of did that for insert into. But for example, for update, I can hard code update. I can hard code people because it's always going to be in the person class. And then the set name equals, let's say I'm updating the name, but I need to be able to get the value that I want to pass in, and I need the ID in order to make this specific update. So I need to take in 2 parameters to my method, and I can use that to add this placeholder in that string and then pass that into my DB execute. So that's where getting comfortable with these CRUD queries will be helpful. What values do I need to pass in for that? And then I'll pause for questions.
Were you just repeating what we had gone over?
Yeah, just in summary. Yep. All right, so now I kind of want to think about how we're going to make these classes communicate with each other in a sense. So before, when we were writing our, I guess we're just like focused on person today, which is fine. When we're in our person class, we defined this relationship between a person and a mountain. We said that a person has many mountains through a hike. And even if we just communicate with the hike for now, we defined a relationship with a person and a hike. We said a person has many hikes. And there was a method in the person class, which was an instance method, where if I said, for example, David.hikes, I will get all of the hikes that that person has basically went on. And you can potentially get the mountain information too. I still want to be able to do that, except now I'm going to be referencing the foreign keys from the table and trying to match them up to make this work. So let's go ahead and see what that would look like. When we're looking at the hike table, if I want to connect the person to the hike, the most important column is this person ID. I need to find all of the person ID that matches up with the hike instance in the table itself. So I'll actually write a query that will go line by line by line, and it'll check the person ID, and it'll see if it matches up with the person that I'm looking at or the hike that I'm looking at. Writing up right here. And we haven't seen an inner join yet in our lesson, so I'll kind of walk through what an inner join is. Joins in SQL are typically going to happen when you're taking a look at 2 different tables and you're trying to find the common data between them. So that's what the inner join is going to do. It's going to look at both of these tables and we're going to give it a column to match on. And for us, our column is going to be the person ID. We're going to say, does this person underscore ID equal to the primary key, this ID right here? So we'll go through and match up where 2 equals 2, for example, if I'm looking at the second one. Person.all will return all of the person, all the people. So I'm going to say like P1 equals person.all, maybe just like dot first for now. So I have an instance that's keeping track of just the first person object. And I'll say p.hikes. So I'm in my hikes method. So I have access to self, which is ID of 1, and the name. So that's what this person object now represents. And I'm going to use this to make my inner join and write my query. So I'm going to say SQL equals. In a join, we're going to start with the table that we're focusing on. Technically, it could be either of them. We can start with person. So I'm just going to say select everything from people. So I'm instead of selecting all of the columns from people, or do I want hikes? Let me do hikes. Well, I think it's an inner join anyway, so it's going to be the same, but we'll say select everything from hikes. And then we'll say inner join with people. So we're joining those two tables together, and we're going to give it what we need to match up on. So I need to match this ID with the person ID from the hikes table. So I'm going to say person.id equals hike.id. So that's what an inner join is going to be. String, and then let me execute it. I always start writing this and I'm like, wait, there's an easier way to do this. So I'll show you the other way too. There's a bunch of different methods you can, or a bunch of different ways you can write this query to get the data that we want. But I just wanted to walk through what an inner join would look like. So I'm taking two different tables and I'm joining it together on one column. So whenever we need to join tables, this is what's going to look like. We'll see if that runs. Yes.
Yeah. Can I, on that SQL query?
Person ID. What's that?
And I think it should be hikes.person ID and people.id, right?
Yeah. Thank you. Yes.
Thanks for letting me jump in.
All right. I'm just like typing words. I'm like, what am I doing? All right. So we're selecting everything from hikes, inner join with people. And we're going to say on table name.id, which is the primary key from the person table or the people table, and hikes.person.id. Sweet. It doesn't like.
You need to add from after the select start.
You all, I forgot in SQL. My brain. Cool. Thank you. Yes, teamwork. Cool. So we have all of the information. It joined the person ID, mountain ID, name, and Sandaria. So it selected all of the columns together. And now we kind of have a new data set that's a combination of person and hike. But now I can take any information that I wanted from the hike table, create that hike object, and return it. Something else I can do, we already know, let's see. Yeah, all of this matches up with what our hikes table takes in. So this is where I can say hike.new. So I'm gonna copy this too. All right, so our first step was writing the SQL query. I think this is the right one, so I'll paste this. I wrote my SQL statement, but this is what my SQL string would be. And
that's the one without the from.
Add from this.
Oh, dang it. Wrong one. Yeah. Thank you. My brain is dead. All right. Thank you, class. And technically, this is not just going to be the hikes for this person now. We just did an inner join for everyone. So this is technically the hikes for everybody. So you can make this a class method if you want to get all of the hike information. But we have a way to return some hikes. And then we can say the step 2 is taking this result. So this is going to be hikes. And I can pass that into my hike.new. So I can say hike.new, hikes dot. This we can, I'll do each for now. And then hike.new and then pass in the variables that I want. So I can go through and pass in ID, name, mountain ID, person ID. The final convention that I kind of want to introduce whenever we're passing in variables and creating instances, it is going to be painful for me to say like hike : or quote ID, quote name, one by one. It's not too bad if I just have one column like I did with person, but as soon as I get to like more than 5, it's going to become painful for me to have to do that in each of my loops. And so there's another way that you can initialize variables in classes. What we've been doing so far is kind of just passing in variables one by one and making sure they match up. But technically you can pass in anything in here. Like it could be an object, it could be a hash, it could be a string. So what we're gonna do is make this a hash, and we're gonna pass in that whole hash, and we'll handle pulling out the proper keys inside of the initialize, rather than having to do it inside of the enumerable itself. So let me show you what that would look like. I guess we're doing this for a hike, so I'm gonna do that for a hike. So what this is gonna look like is this will become a hash, or let me cut this out, and I'll put this as a comment outside. So I'm gonna take out each of this, and for this, I'll just say hike. So I'm gonna pass in a variable called hike, and this is really going to be the hash that I want. So I'm going to, in here, pick out the keys that I want inside of the hike itself. So the values are exactly the same, except this is going to come from this hash that I'm passing in, and I'm not just passing in each variable now. This makes it easier for me when I create my hike, because now inside of here, I can just pass in the hike itself. Because we know that when I query this from the database, it's going to have an ID, a name, a mountain ID, and a person ID. That's what my database has. So I know for sure when I create this hike, and let me make this a map. When I create this hike, it's going to be the keys that I want.
Does the sequencing make a difference then? Make sure things
Nope.
map correctly? Oh,
Yeah,
wow.
that's a great question. Yeah, it's the best part. You don't have to worry about order anymore. As long as you have the key value pairs matched up, that's all that matters. So moving
cool.
forward, yeah, our life is going to be made easier. But at the same time, what you need to pay attention to is now when I pass in parameters, I can't just pass in strings anymore. I also have to indicate the key and the value, which you'll get some more practice with. If you're passing in a hash itself, it's fine. But if you want to pass in the mountain ID, person ID, name one at a time, then you also have to put the key that it belongs to. So let's see what this does. I wrote some code, kind of hard coded this, but that's all right. And I would say for our scope of mod 1, you just need to be comfortable with inner join, and you should be good to go. So as long as you kind of understand for an inner join, we're matching up these IDs to find the common values, you should be fine. There's also left outer join and all of the other joins out there, but you'll never really kind of work with that unless you're creating like databases in the industry. All right, so I should have made this a class method, but it's all right. Let me create that P again. So I, just like our hike.all, I said p.hikes, and I got a list of all of the hikes that, this is just a list of all of the hikes that this potentially a person has made. So it's behaving like a hike.all, and we'll need to take it one step further to find all of the hikes that this specific person has made. I kind of did this just to kind of show you what an inner join will look like. However, something that you can do if you just want to make this an actual instance method, rather than just doing a select all with an inner join, you could just do a normal select and find the ones with the matching ID of 2. So we can say db.execute. We'll say select all from hikes. ID equals, we'll put the placeholder, and then I'll make this ID. So this ID is going to be the instance that I call this hikes on, and I'll be able to get the hike objects from there. And I'll make this hikes And we'll just enter this here.
And then ID equals question mark would be person ID equals question mark, right?
The person ID. Oh, thank you.
Or
Person ID.
person ID.
Yeah. I keep on thinking I'm looking at the person table, but it's not. Cool. P dot cool, and then P dot hikes. Have I made any? Oh yeah, I've made a couple. So I've made 2 hikes, but the main part is person ID is 1. So now I have a way to get the person ID or the hike objects for that. And I can use this to find my mountains. So if you remember from the code challenge, it's basically the exact same thing where you're communicating with the join, you're getting all of the data from the join, and then you're communicating with the has many through. You can use whatever's returned from here to find all of the mountains, because you can find all the matching mountain ID from the hike objects. It can get as nested as deep as you want. But this is how we're going to communicate between classes now. Taking these foreign keys from the table and matching it up with the primary keys in our relationship. So the relationship is exactly the same. We have people have many hikes, mountain has many hikes. Hike still belongs to a mountain and a person because it's keeping track of the mountain instance, except right now it's the ID instead. And we can still get to person from a mountain because of this hike. We can say mountain has many people through hikes. So that's why the relationship stays the same, but how it's represented in data changes. I'll pause for questions.
Any of the Learn.co labs walk this through or at a slower pace? Because theoretically it makes sense, but right now I'm like, oh, it lost me.
I'd have to take a look at specific labs. I think there are some, like the ORM labs should go through all of CRUD for you. So you can start looking at the ORM labs. That's basically what this is, us going through CRUD for ORM. I do want to say before we kind of end it, this is a lot of information to remember, and it's a lot of queries to implement, and your tables talking to each other with the inner joins, all the different joins you can kind of create. You potentially will not have to remember all of this stuff. So don't worry about remembering the syntax or like what an alter table query is gonna do. As you saw, even I forget the syntax sometime when I'm writing it. Starting tomorrow, we are going to learn about a framework that we're going to include called Active Record that will implement all of this for us. So we won't have to. So you don't have to worry about remembering this. And let me take it back to my visual, which is why I stress the why behind how these databases are communicating more than the actual syntax. Tomorrow, move this. I feel like it always gets slow. Move. All right. So tomorrow we'll be learning about Active Record. And let me make this a little smaller, which is the exact same structure. We still have our database, which is our nature.db right now. We still have our connection, but instead of using the SQLite gem, we'll be using the Active Record gem. We still have our classes. However, Active Record will give us all of the methods and all of the connection that we need to communicate with the database. So it will be handling the class CRUD for us. It will be handling the connection for us, altering the schema, altering the database, and implementing CRUD, which will be cool. So don't worry too much about the nitty-gritty syntax of how to implement this CRUD. What I want you to understand is all that's happening here is there's a SQL query that we need to implement against the database, whether to insert data or read data, update, delete. And there is a tool that's implementing those queries for us and giving back data. That's it. So we're implementing queries and retrieving data and using them inside of our program. That's the main premise. Pause for questions.
So I know that we're going to be doing the Active Record thing tomorrow, but from all of everything that you just showed us, what would you say is like the main takeaway despite not having to exactly memorize all of it?
The main takeaway I would say is the idea that we have these classes that we've implemented for all of the tables in our database. So we have a bunch of tables in the database right now. We have hikes, mountains, and people. And somehow we have a way to represent this structure inside of our program, where we created a class for each table. And we said, all right, in the table, I have a name ID, so I'm going to add that as attributes for my person class. And inside of here, I have a bunch of methods that are executing SQL queries to the database and giving me data back. So this part here, I would say the flow is the most important part, where when we're writing this method, we're thinking about what is the SQL query going to be? If I need to take in any extra parameters, what do I need to take in for this method? And what am I going to do with the data that's returned? And typically, in the world of Ruby, we need to be working with objects. So we're going to take that extra step of converting it into an object so we can use it somewhere else. So that's the main concept that I want you to understand. The specific things about like inserting the hash with the proper key, this I feel like you'll kind of get used to with more practice, but you'll never have to like know specifically what it needs to be. And also the hash thing, like get comfortable passing in hashes instead of just instance variables for the initialize. Yeah, that was a lot of information. After going through it, I'm like, okay, there's a lot we went through. Any other questions?
Can you scroll back up to where you set the hash?
Yeah, that's in the height class right here. I would need to change this also to hike.
Okay.
Oh wait, I
So
don't want to
then
like.
when you do the initialize hike, you're turning that into a hash where it contains the, all that data within hike, right?
Yep.
Because you're creating a new, you're basically like not pushing, but you're creating new hashes by doing hike brackets value.
In this case, I'm not creating a hash. I am taking the values that's coming in from the hash.
Yeah.
So let me put a
Right,
standing down price. Yeah, that's probably what you meant, but yeah.
Yeah, that's what
now. So this hike is going to have, it's just going to be the whole thing that came from the database. And then we'll kind of parse through it and pick out the values that we want.
Okay.
Let me see if I can implement a hike.all. What? Cool, so I did hike.all. Right now it's no. Let me see what hike is. Cool. So I did a hike.all, and from the database, because of that results as hash, this is what I get. And I can just pull out person ID, mountain ID, name, and ID.
Sweet.
And technically, if you're working on a lab and it's an array, then you'll have to do the bracket. And this helps us because we don't have to worry about the order anymore. We don't have to worry about what values are there, what's not. We can just pass in a hash from the database and directly use it. All right, any other questions? Cool.
So if we don't have anybody in a database, then we will still need. So if somebody went on their own trip, they want to like record it in our little like mountain project app thing that we have here.
Yeah.
We then need another method or even class, I'm not quite sure, that would then collect the data from the end user and put it into the data, because some of this, they were pulling out data already.
Yes, so similar to our, I think we did that in person, this insert data here, where we had to create a person first and then we use that value to insert. We'll be doing something similar here. Okay. Except for hike now, we need to pass in a hash and not just values anymore. So it's taking in a hash and we need to say name, hike, new hike. And we would say mountain ID is 1, person ID is 2, and then ID is going to be nil. So we can say like ID is nil. It'll automatically do this for us, but if we want to, we can add it. So now instead of passing in just the strings and the comma value, I'm passing in that hash, and it'll be able to use that to make it. No, dang it, Ruby. Okay, this has to be a string. I always forget in plain Ruby, these are all, it has to be exactly a string. No, I need to figure out how to get the string values. What is this coming in as?
If you do in the instance variable assigns, all like hike name is a string. If you change @name equals hike symbol name, it'll work, or should.
So now it's expecting a symbol.
Yeah.
Dang, okay. Yeah, you'll have to pay attention to the symbol versus string, which is kind of frustrating. Oh, Ruby. But I would keep it a string because that's what the database is going to give us. And we'll have to format it as a string when we create it. So I think it has to be like, maybe.
I think it forces, when you pass the hash into the parameter like that, I think inside the initialize function, it forces it into a symbol.
That's sad.
Because like, yeah. So like,
one last thing, we'll see if it goes through. Oh well, if they stick with the string, okay, cool. That's such a painful syntax, but when you want to use strings, you have to do the hash bracket the long way so that it forces it to be a string. But by default, it converts it to a symbol, which is like, okay. So technically, since from the database, we're getting it as a string, I would keep it like this and just pass it as a string when you create it in your project. So if you're creating Ruby instances within your project, you'll have to use this. However, this will be made easier for us later because we'll, when we introduce Active Record, it'll convert the symbols into strings for us so that we don't.
Can you put a note of this within the code or the README so that we can see this later?
Yeah, let me add that here. So the official term for passing in those hashes for known as mass assignment. So we're taking in that whole hash and tossing it in. So I'll say, when you are creating Ruby instances in your project, not from a database, you will be passing in key value first. And then I'll add the code. Except it's typed out in. Cool. I'll add this. And if you're looking for a sample to follow, you could just use this as a sample.
Thank you.
Yeah, thank you. I'm going to be better at documenting this in our README. Any other questions? Thoughts? All right, I'll wrap this to a close. So we kind of went over Ruby and SQL again, so how we can integrate a database into our code, and started sort of talking about going through examples of now how can I make my classes talk to each other like I did before. And the main part is the foreign keys. Without the foreign keys, hikes would not be able to know what person it belongs to, person would not be able to find how many hikes they have. So we can still implement those methods. We just have to match up the foreign keys for that person to that hike table, and for the mountain to the hike. So the process will be the same, except now we're talking to those tables. All right, so get comfortable implementing more CRUD methods in ORM. I do recommend you start looking at the Active Record labs so that you can be familiar with how we're going to integrate Active Record into our project. To get better practice, I like using something that you're familiar with. So I'll be taking this project and I'll be converting it into Active Record and how we can incorporate that gem. So we'll still work with mountain hikes in person. You'll be sick of hikes after this mod 1 because we built out everything for it. And then I'll just convert it using the gem. So we'll replace the SQLite gem and go step by step on what that would look like. All right. Let me stop recording.